Hi guys, Mrs. Delis in here. Welcome to another lesson of Algebra 2. Today's lesson is the square root graph. We are first going to look at how the parent graph of a square root function or a radical function looks like. We'll start with this table. Fill in the table below. Leave all the decimal values accurate to 4 decimal places. Use the values to draw the graph of f of x equals the square root of x. We have here a column of all the x values, and we have a column of all the y values, or our f of x. Now, how did I get all these values? Okay, for example, I have if x is 0, so I did f of 0. That's the square root of 0, so that is a 0. Then next, I had f of 1. Square root of 1 is equal to 1. And then I did f of 2. Square root of 2 is equal to 1.4142 using the calculator. And I did all of the rest by just plugging in the value of x into the square root. And then, of course, I just wrote every single number, but you could always pause the video so you can write all the numbers. Now, I am going to graph the values. There are so many decimals going on in here, but I'll just focus on the integers. I'll just focus on the whole numbers. Let's take a look in there. And then, because we just really want to know how it looks like. So we have 0, 0, 1, 1. We have 4, 2. And then what we have? We have 9, 1, 2, 9, 3. And then all I have to do is just connect these. And we have our square root graph. Okay, now what do you notice with this graph? It looks like we don't have a negative x values in here, yeah? And we don't have negative y values also. Why is that? For number 2, why should we not use negative values? Why are we not using negative values in here? Like say, for example, I'm going to add in x is equal to negative 9. Why can't I use that? So if I have x equals negative 9, so that's f of negative 9, I will then plug in negative 9, and that is a 3i, right? And because this is 3i, it's an imaginary number. And that's the reason why we're not using negative values of x. Because negative values of x will be imaginary. Okay, imaginary numbers. There you go. What is the domain? Remember, domain is a set of inputs. Domain is all the x's. And then number 4 is what's the range? Remember, range is all the y values, or all is a set of outputs. When I say domain, then we're looking at all of these values, or all of these values right here, right? If you notice, we don't have a negative x value. In quadratic function, in the previous quarter, we learned that the domain of a quadratic function is all real numbers. But in here, it does not look like it's all real numbers anymore, because we don't have negative values of x. And so we take a look, and it looks like we started with 0, and it increases all the way to 10. But of course, we could always use x equals 11, x equals 12, and so on and so forth. So our domain in here is x is greater than or equal to 0. Now let's move on to our range. Our range is f of x. We always write it that way. And if we try to look at our domain, our set of outputs in here, it does not look like we have a negative value, right? So our range is going to be also greater than or equal to 0. Okay, Now that we have an example of how a parent graph of a square root function or radical functions look like, we are now going to learn how to describe transformations of the graph. Now, before watching this video, I highly recommend, or before continuing, I highly recommend that you watch Quadratics 4.1 video describing transformations. So that way the transition is not going to be hard for you. I'm going to start on showing you the transformations of the square root function. When comparing a function g of x into f of x equals square root of x, right? We have a new look, which is g of x equals a square root of c times x minus h plus k. So remember now, the k is outside the radical, the a is before the radical, we have c before the x, and we have h inside the radical. In a previous lesson of 4.1 describing transformation, we've already learned the sign of a. If the sign of a is less than 0, so if a sign of a is negative, we will say reflected across the x-axis. So the a is negative. When the a is positive or greater than 0, then we say no reflection across the x-axis. And that is when a is positive. Now, moving on to the value of a. The absolute value of a, meaning it's going to be always positive. We don't care if it's a negative a or a positive a. We care about the value itself without the sign, right? So if it's a negative 3, then we look at it as a positive 3. It's the absolute value of it. So if the absolute value of your a is greater than 1, so we're looking at 1.5, 1.2, 2, 3, 7, 8. If your a are those numbers, then we say vertically stretched by a factor of whatever the a value is. If a is in between 0 and 1, so we're looking at 1/2, 1/3, 1/4, 0.1, right? Then we say vertically shrunk by a factor of a. If a is equal to 1, then we say no vertical stretch. Those are the things we've learned before. Now h, the value of h and the value of k, the value of h is the horizontal shift. And the horizontal shift either goes to the right if it's positive, goes to the left if it's negative. The value of k tells us the vertical shift. So if it's a positive, then it goes a vertical shift up by that unit. If it's negative, then it will go vertical shift 5 units down or 6 units down if your k is a negative. The only additional here that we have not learned before is the value of c. So when you look at the value of c, this is something new, because if you take a look in here, we now have a c value, right? The value of c can just only two possible options. It can only be c equals 1 or c equals negative 1. When is it c equals 1 and when is it c equals negative 1? I will explain further when it's 1, when it's negative 1. But for now, I would like you to understand that when c is equal to 1, we will say no reflection across the x-axis. When c is equal to negative 1, we say reflected across the y-axis. Okay? For now, that's all we need to know. All right, for the domain and range. When we learn quadratic function, the domain is always all real numbers. So it wasn't that hard to actually know what it is because it's always all real numbers. But for the square root function or for radical functions, the domain is no longer all real numbers, right? Just like what we witnessed earlier, the domain was greater than or equal to 0, right? So for the domain in here, how would you get it? First, you set the radicand. The radicand is the number under the radical. So if I say square root of x minus 3, then x minus 3 is what we call the radicand. Your job is to set the radicand greater than or equal to 0. So whatever I find at the bottom, we call that radicand. Whatever I find in there, I will take that out of the square root and I will make that greater than or equal to 0, and then I will solve for the value of x. For the range, very simple. When a is greater than 0, so the symbol would be greater than or equal to k. Because when a is greater than 0, that means your graph is facing up. If a is less than 0, that means your graph is facing down. And so you are going to use less than or equal to k in here. This is greater than or equal to k. Let's start with example number 1. Given g of x is equal to 3 square root of x minus 2 plus 5, your job is to describe how the parent function transform, and you have to state the domain, the range of the function. Now, this is what we graphed earlier on before when we started this lesson. This is how the graph looks like. That is what we call the parent function. But this right here is this graph, right? And we are trying to describe how it transforms. So let's take a look from here, right? The starting point, this is also the starting point. We call that the vertex. The starting point went to the right, and then the starting point went up, right? So we will describe that transformation after. But before that, let us describe the letters A, C. Let us take a look how we got the letters A, C, H, and K. Now, remember, g of x is equal to A, C, x minus H plus K. So let's start with A because it's very easy to identify. It's the one outside the radical. So this is our A value. And of course, our K is the one outside the radical to the right. So this is our K value, right? Not a big deal. Now, the C value, remember, is either a positive 1 or a negative 1. It's a positive 1 if the x is positive. It's a negative 1 if the x is negative. We take a look in here and it looks like we have a positive x, right? There's a plus there, right? And because our x is positive, our C value is a positive 1. Right? And then, miss, why is this x minus 2 negative 2, but then my h is 2? Remember that you would always make that equal to 0. So x minus 2 equal to 0, add 2 on both sides, x is equal to 2. Therefore, your h value is equal to 2. Now, let us describe the transformation. Because our A is positive 3, we would say no reflection across the x-axis. If our A was a negative, I would have said reflected across the x-axis. Moving on. Because I have a 3, if your A is above 1, you would say vertically stretched. If it's below or in between 0 and 1, you would say shrunk. And because this is above 1, I would say vertically stretched by a factor of 3. All right? This one is for my C value. My C is equal to positive 1. So I would say no reflection across, take note, across the y-axis. Meaning to say that, so if the C was a negative, then you would say reflected across the y-axis, right? Okay. Now, for horizontal, for H value, H is equal to 2, and that's our horizontal shift. If it's a positive, it's going to the right. So horizontal shift 2 units right. If it was a negative, I would have said horizontal shift 2 units left. But if you take a look in here, it's from here, now it's there. So it did went to the right 2 units, and it went up by 5 units. That's why your vertical shift is 5 units up. Okay, now how do we get the domain and the range? And this is critical because the domain, there is an extra step that you have to do. According to what we read earlier, to get the domain, you will set the radicand greater than or equal to 0. So it's over here already, but let's take a look at how we got that one. So we have the radicand, the number under the radical is x minus 2. So I would do x minus 2, set that greater than or equal to 0. Instead of an equal sign, we're setting it greater than or equal to 0. That's the rule. And then we'll solve for x. So that's add 2 on both sides. So we have x is greater than or equal to 2. And so our domain is x is greater than or equal to 2. For our range, very easy. If a, what was that again? If a is greater than 0, if a is positive, then the symbol we're going to use is greater than or equal to k. If a is negative, the symbol we're using is less than or equal to k. And because our a is positive, our range is g of x such that g of x is greater than or equal to 5. And what that means is, if you look at the graph over here, the range started from 5, right? The y started from 5, it went to 6, it went to 7, it went all the way up, right? From 5 and above. And that's why we said that the range is greater than or equal to 5. Okay? Moving on. Over here, we're going to have 2/3 square root of negative x plus 3 minus 7. Let's get our values. We have our a value 2/3. And because our x is negative, our c is negative 1. Our k value is a negative 7. And of course, this right here, negative x plus 3, right? Negative x plus 3 can be rewritten as negative x times x minus 3. Thus, we can rewrite this function as g of x equals 2/3 square root of negative times x minus 3 minus 7. But that could be a little bit confusing, right? So you can always just copy it and make it equal to 0. So you have minus 3 on both sides, negative x equals negative 3. And of course, you would have to take away the negative, yeah? You divide both by negative. So your x is equal to 3. And that's the reason why your h is positive 3. Okay, let's describe. This is a equals positive 2/3. Because we don't really care that it's 2/3, we care that it's positive. A is 2/3. This is c is equal to negative 1. H is 3. K is negative 7. Alright. Because our A is positive, we would say no reflection across the x-axis. Right? No reflection across the x-axis. Moving on. Our A is 2/3, and because it's a number between 0 and 1, we say vertically shrunk by a factor of 2/3. If this A was greater than 1, then I would say stretch, vertically stretched by a factor of 2/3. C is a negative 1, so I would say reflected across the y-axis. If the C was a positive 1, I would have said no reflection across the y-axis. Okay, we're good. And then, moving on, we have horizontal shift 3 units to the right. If you look at the graph, it's here, and then the vertex is now in here. So it went 1, 2, 3. It went 3 units, and then it looks like it went down by 7 units, right? So vertical shift 7 units down. For our domain, you already know the deal. We will copy the radicand and we'll set that equal to 0. And then we have subtract 3 on both sides. You'll end up with negative x greater than or equal to negative 3. Now we will divide by negative 1 on both sides. So that is x, and this is positive 3. But remember now, do you guys remember this? If you divide by a negative, your inequality symbol changes its direction. So instead of a greater than or equal, it is now going to be less than or equal to 3. And that's the reason why my domain is less than or equal to 3. Of course, for my range, if you have a negative a, it's going to be less than or equal to k. If you have a positive a, it's going to be greater than or equal to k. And because our a is again positive, my range is g of x is greater than or equal to the k value, which is negative 7. Okay, I will give you last example. We have here, given g of x is equal to negative 2, I always say times, so but yeah, it is times, square root of negative x minus 4 minus 3. We will take a look at our a value, negative 2, our k value, negative 3, our c is negative because the x is negative. So c is negative 1, and remember, your c is either a positive 1 or a negative 1. And then, I will set the radicand to 0, add 4, negative x, divide by negative 1, so your x is negative 4. And that's the reason why my h value is negative 4. Now, describe the transformation. This belongs to a equals negative 2, a equals 2. Remember, I don't care about the sign. It's the absolute value of it. Reflected across, so this is c equals negative 1, h equals negative 4, k equals negative 3. Whoa, too many negatives here. Okay, let's take a look at our a equals negative 2. Because it's a negative a value, we will say reflected across the x-axis. So you know how originally it's facing this way, but now it's facing this way, right? So it reflects across the x-axis. You know how like they are, one is increasing and this one is decreasing. Okay, now vertically stretched by a factor of 2 because our a is greater than 1. If our a was between 0 and 1, I would say vertically shrunk. C is negative 1, so reflected across the y-axis, right? And then we have h is negative 4, so horizontal shift 4 units to the left. Let's take a look if it's true. So the original vertex is here, now it's here. So if it's 1, 2, 3, 4, it went 4 units to the left, and then it looks like it went down 3 units. So vertical shift 3 units down. For our domain, we will set it greater than or equal to 0. So that's negative x minus 4 greater than or equal to 0. Negative x greater than or equal to positive 4. And of course, when you're dividing a negative or multiplying by a negative, the sign or the direction of your inequality changes. So our x is greater than, our x is less than or equal to negative 4. Now let's verify if that is true. Is our x value really starting from negative 4 and below? Yes, it is. It starts from negative 4 and below. So, there you have it. And for the range, of course, same. If A is positive, it's greater than or equal to K. If A is negative, it's less than or equal to K. Because our A is a negative value, our range is less than or equal to negative 3. Okay, I hope you have so many examples. You also have example number 4 that you can take a look at and practice some more. And I hope that this lesson helped you a lot. And I could maybe, if you need another example, we could do another example. We can do example number 1. So here we have our A value is 3. Our K value is 4. Our C value is negative 1. Our H value, of course, you copy that first and you make that equal to 0. Negative 6 divided by negative 1 or multiply by negative 1. X is equal to 6. And that's the reason why our H value for that example would be a positive 6. Okay, let's move on. This one is for A equals 3, positive 3. A equals 3. C negative 1. This is for H6. K 4. So let's start with no reflection. Why is it no reflection? Because the A is positive. No reflection across the x-axis. Because the A is a number greater than 1, this is vertically stretched by a factor of 3. And because C is a negative 1, this is reflected across the y-axis. Don't forget. And then for H, that is your horizontal shift. Because it's a positive, it's 6 units right. And then this is your vertical shift. And because it's a positive, this is going to be 4 units up. Okay. Now for the domain, all you have to do is set the radicand. Radicand is the number inside the square root. So you have negative x plus 6 greater than or equal to 0. You always set it greater than or equal to 0. Negative greater than or equal to negative 6. You're dividing both sides by negative, so the symbol will change its direction. Your inequality will change its direction. So your domain is x such that x is less than or equal to 6. And your 4 range, if A is positive, then it's greater than or equal to K. If it's a negative, then it's less than or equal to K. Because our A is positive, we would use greater than or equal to K, which is 4. Alright? I hope this lesson is not that bad for you. If you have any question, please don't hesitate to ask me, to email me about it. And thank you guys for your patience. Thank you for watching. And I will see you guys on the next video. Thank you.